Node scalability and cluster. Scalability and child processes. Scalability and child processes. Say that really fast 3 times. And then clustering. Scalability. So this is more advanced noding, but it kind of gives a good overview of why we're learning Node. So typically in hardware and machines, we have CPU cores. Our typical operating system OS has different running processes running in the background. Each process is managed by a single core in one of our CPUs, right? So we have a single core. However, you look at that chip there on the left, we have 4 cores that we could utilize. So in order to take full advantage of the CPU, we would need a number of processes that equal the number of cores in our CPU. Previously, we limited ourselves to using a single node process on a single CPU core. So maybe we've been working diligently in our node process over here, right? For everything that we've done. We may need to do more. Maybe we have to process high computations. We need to utilize all cores, right? We may have a very complicated problem that does something like calculating the DNA structure of an organ donor, right? I told you about that job situation that I was very interested in, but I didn't get because, well, someone who is a Node.js developer beat me out. I'm a full stack developer, so I was happy to almost get it, but some guy who had a lot of experience was able to best me out, and that's how it happens, right? Sometimes you're going through the process when it comes down to 2. One person wins, and the next person goes on another job. But I can't complain. I landed on my feet pretty well, so it's okay. So single process limitations. So we have CPU there at 4 cores. Single-threaded, non-blocking performance in Node works great for a single process. It is good for a single process, but eventually one process in the CPU is not going to be enough to handle, some workload of your application, especially if it's very heavy. Something like streaming many movie trailers if I would have done that example the other day with, I don't know, 20 browser windows serving up the same video and playing it, I'm not too sure what my system would do, right? Especially while I'm screen sharing with you guys. So Node.js runs in a single thread, but that doesn't mean we can't have multiple processes and multiple machines running our code. So this is multi-processing versus multi-threading. Typically, multi-processing is adding more number of CPUs to the system, which will increase the computing speed of the system, right? We add more CPUs, we keep expanding horizontally. Multi-threading is allowing a single process to create more threads, which increase the responsiveness of the system, right? So you may be working with a single process, you want to multi-thread it. However, we may be using just one core in CPU, right? So the reason why Node is called Node, by the way, is because it's built for scalability. Scalability is built into the core Node runtime. Node is called Node because we want to emphasize the fact that a Node application should comprise multiple distributed nodes that communicate with each other. So we can break out all of these things to different nodes that all communicate to each other if we needed to scale in this way. We have that flexibility, much like MongoDB can also be scaled into shards. We can also scale with Node as well. So Node has a built-in module to help with this. You don't have to get any package or anything like that. It's built in. So running multiple nodes for your Node application, so if your built-in module will help you run a Node process on every single CPU core of your server. And I have another load balancing all requests on all distributed servers. If you were to really scale this out, you can scale it out in a pretty powerful way. One would be to use child processes. So we have this module called child process that allows us to do a couple things. You can see there on the left, we can spawn processes, we can fork them, we can do some execution on them, and execute file. Those are different ones, but spawning and forking are probably the ones you use the most. This module allows you to access the operating system functionality by running any system command line inside a child process. We can also control the child process input stream and listen to its output stream. There's 4 ways to create a child process as pictured in there. All right, so let me take a look at one example. I think it was of executing a child process. Now remember, this may get a little bit intermediate to advanced. It's fine. We're not going to do a lab or we're not going to be tested on this, I don't believe. I'm pretty sure I looked at the exam and it's not on there, but you can quote me on that. All right, but just to know what it does, we'll walk through a little bit of code. So, all right, so we have a child process. We're going to do an exec. So exec returns the whole buffer output from a child process. We're going to run I think some of this may not work on Windows, but we'll just talk through it. Run an update Unix function, Windows system info. So if I wanted to run some Unix commands on this guy, I could run a Unix command like a pipe. And basically, we're trying to trigger this command and run it. Let's see if this guy works, by the way. I recall trying to do these live, and I don't think I was able to run them on my Windows box. Let's see where we are here. I want to open this guy right here and take a look. I recall with some of these, yeah, I had some issues running them on Windows. All right, so I think some of these actually required me to run some. Oh, you can see that actually. It actually did it. I'm sorry. I'm surprised. I'm surprised I didn't have a problem. I remember I actually had problems running this one. Okay. So what it did is it actually did execute this system info command. So internally, Windows knows what this this system info command is. So we have a child process, and we execute on this child process this command, and then we were able to get the output of this guy in the callback and output it to our current running process, right? And what it did was it went off while my main process was running. Let's take a look at that again. That's my child process ID. It's going to go run something, and when it gets the information back on its standard in, it's going to write output to this current running process. So we kind of branched a process out there, and he came back with the information. It took him a little while, well, not too long. And this was a system info command. You can see on standard in, it gave me a pretty good information on my operating system, everything I need to know about virtual memory, physical size, my network card, everything. Hyper-V for virtual machine. Do I have everything enabled if I want to create a virtual machine? Great. Okay, so that's pretty cool. And that was a way to create a nice child process using this exec command, right? To be honest, I usually don't use too much of them. I use spawn. So spawn, and again, let's see if this works with these commands. So we want to spawn a child process. Then we want to spawn some commands, right? We actually want to go out and spawn another child process that's going to do a window ls. And then we're going to do another command, just like a grep. It's going to do some find, right? So we're spawning we're going to try and spawn a couple processes to go out and do a bunch of commands similar to if I did a dir, right? If I did a listing, a directory listing, you can't really see it, a dir command. The dir command or a clear command, sorry. Let's go back to this guy here, clear, right? Clear, CLAR. dir would be the same as ls in Unix. And that would list the directory structure. That's the idea. The other one would try to find, this one's trying to find something, find string. I guess it's trying to find child or something like that. Ideally, we kick off a couple child processes. The return process will hold a property for each stream, standard in, standard out. So we want to try to, we want to get the result of this PS and output it to our standard in. Actually, what we're doing is we're trying to pipe responses, right? And we're trying to give some information on it. Now, that's the idea. So think about it if you visualize it. Spawn, we have two window commands we want to run. We want to go and spawn two children to go and do them, and then report back to us. And then when they report back to us, we're going to output them. That's the idea. Now, again, I'm running on Windows, so let's see if this guy will go and work for us, these guys. No, it didn't like these commands. Let's see here. So I think that's the problem with these commands. dir, oh, I'm sorry. What did I do? Spawn 2, try it again. Mine basic. Yeah, it didn't like something here. Oh, it's because I typed this, my bad. I tried to do dir in here. Try it again. All right, so we actually got a response from, the listing. Then we piped it into the grep command, which, if you notice, it gave us a listing of all the files that had a child. So this is like a find all, like a wildcard. So you can see here, if you look in my basic folder, I have 1, 2, 3, 4 files that have the extension child. I have one file that has an extension of, or a suffix of parent, one that has cluster, temp, timeout. So these other ones were ignored. So I would think that if I change this guy to parent, it's going to go in ls. It's going to ls the. It's going to output. Let's see what happens. It should only output one. So you can see there, it actually only outputted one guy. So it did a command. It outputted the entire directory, piped it through to the other process that actually outputted this one file we were looking for. So you can pipe the responses to the processes as well. It's interesting. Okay. All right. So it gets, again, like I said, just look at the fact of what we're doing. I don't expect you guys to understand all the code right out of the gate, right? Especially since you're not going to be having allow on it. But anyhow, as we're scaling, every child process has the same event emitters and stream, has event emitters, events, and streams. So we can pipe them together, which you just saw. We can listen to things. We have similar events we can register a handler for on these instances of the child. Exit, disconnect, error, close, message. We can send messages across, which is super cool. There's a message event, just like on our web sockets, how we send messages across the socket. We can send messages to each process, each child, adjacent sibling, or the parent process. Actually, you know what? The example I have has parent and child process communication with each other. I think in order to send a message to the sibling processes, you need the child process would have to send the message back to the parent, and the parent would have to broadcast out to all the child processes, right? Much like how the sockets work. Every child process gets 3 standard in streams that we know: child standard in, which is like console log. Child standard in is the input. Standard out is like console log, and then of course the standard error. Since all streams are event emitters, we can listen to different events attached to the child process. The one we looked at was called spawn. We first looked at exec, but spawn is probably one of the most common ones you will see. This is what it looks like. We have the spawn. It takes a command, some options. So the spawn function launches a command in a new process, and we can use it to pass that command on to any argument. The result of spawn is a child process instance, which implements the event emitter. We can register event handlers for these events directly on the child itself. This may not make much sense right now, but let's look at an example for spawn. I think we looked at this one already. So this would be, all right, we can look at this one. This is not too advanced. It says advanced, but this is basically using destructuring to pull out spawn. So we could do it this way. I want to create a child from this spawn event, and I want to do npm. I want to do npm. The command will be npm. The option I'm getting it is the version. So what I want to do in this would be the same as writing on the command line, npm minus v. npm minus v. I should get back version 16.14.8 so it says without the shell option. So the shell is true, so there's an option for the shell. I forget if that causes a problem or not. Then we want to set up a couple listeners on this child process. On standard out, when there's data, console log the data, right? So when it goes and executes npm within that process, that's that other process in this running one, right? There's two of them now. We want to listen to him and pipe out. So when the child gets this response, we want to also output it to our console log so we can see it. If the child has an error, we want to see it. If the child closes, we want to see it. If the child exits, we would like to know why he exits. We would say child process exit with, and then here's the code and the signal, right? So ideally, that's what we would like to do. Let's open the terminal window. Node one. All right, so you can see there the data we spawned, child process, it went away and ran the command npm minus v. We got the data back here. And then it was ready to close. It was closing, but on exit, this is where we said the child process, and you kind of see you can kind of see it exited first and then closed, right? So the child process exited with code 0 and a signal of null. So that means it exited fine. There was no errors because it's 0, and there was no signal that was given to it. So I wonder what would happen if we had a delay in there, or if I try to run this guy and then quickly try to interrupt him. I don't know, let's try it. Quickly edit. Oh, it didn't capture it. It did exit, but I terminated my currently running process. The child process wasn't terminated. Yeah, it gets confusing, right? It does, because it gets very confusing, right? But if the child somehow got interrupted, we would know about it because we're the parent right now, in a way. Like I said, this is advanced node. This is when it gets a little bit confusing, but interesting, right? So, all right, so that's spawning a child process, right? All right, continuing it on, that's spawning. So now this little example makes a little bit more sense here. You can see it's the same thing. Really, we're just trying to trigger this command, and then we're trying to listen to it, see if it worked out. The shell command. So the shell command, if you notice, I was even thinking about that, the shell option to true. The shell is the command line interpreter, or the shell that provides the command line interface. That is the shell, right? The Mongo shell. So when we were doing Mongo, we could work inside of the shell. Remember that? I kickstarted the daemon, and I also kickstarted the shell, the UI that we could interact with MongoDB. We could interact in the shell, or we could use the UI Compass, Mongo Compass, to interact with it. Because let's face it, the shell is not very user friendly. It is it's kind of scary, right? So the bash command line shell may be scary as well, right? So bash is the command line shell we use to run our node commands and shell scripts. Node provides us a function that will span an instance of the bash shell and execute these given commands. So we can spawn the shell within our child process and execute all these commands within it. That's how we're getting back. It's like, oh, how am I running npm command in the process? That's how. It spawns a little tiny container for these shells, the shell, and then within it can execute commands. That's what it's doing. This function is called exec and returns standard out. So you can see here, that's a list directory on shell. So let's take a look at that. So exec function, if we want to run commands in the shell, we can use exec. So spawn doesn't create a shell, so it is more efficient. So spawn doesn't create the shell. It doesn't create the shell. It's more efficient than exec. So if this makes any sense, so we can utilize the shell. We don't have to create a new one in spawn. So that's what I'm saying is you may use spawn a lot. I'm just showing you this option. Exec. This is another option. Exec. We used it. Buffers the output and passes it as a callback to standard out instead of streaming, which spawn does. So spawn uses streams. Spawn doesn't recreate the shell all the time, so spawn is more efficient, right? So the spawn function is more better choice when the data is large. So quite often, like I said, I always use spawn and I use fork. Exec file, another one that you can use, but again, the other two use most of the time. So exec is very similar. Exec file is very similar to exec, but instead of launching a process and executing the command, the file parameter is executed directly. So I imagine it's executed directly without launching that whole new process, right? So if you want to do exec. So again, I don't use this one that much, just so you know about it. Fork is a specialized version of spawn. We'll get to that in a second. So just be aware of these ones. And where's this example here? So, all right, so these are forking. So fork child, fork parent. All right, so we're talking about forking. Okay. So the takeaway is, I would say, this is the fourth one in this original diagram here, right? So we said from the beginning there was spawn and fork are the ones that are used quite a bit, and these other ones, exec and exec, not so much, because these are more efficient, right? Just so you visualize that. The last one was forking. So it's a specialized version of spawn, especially for creating node module processes. So similar to spawn, but it also adds the additional functionality of sending messages. The send function and the message event to facilitate passing messages between parent and child. So if you want to have communication and send signals back and forth, if you need to spawn a database process that goes and deletes the database, and when he's done, the child process needs to tell us that he's done, and therefore we know to terminate that guy, and then we need to, I don't know, do something else, spawn another database process or do something else. If we want to have communication channel, we need to use fork. That's the difference, right? So spawn if we don't really care about sending messages, forking if we want to send a message back. This example here, you can see we fork a child process. We give them a file that is a timeout. When the child gets within that file, it's going to send a message back to us. When we get the message, because we're listening for the message, it's going to basically tell us we're done. And then we're going to send a message back to the child to say, I'm done, something like that. I have to look at the file. And then we send it off. So this is we'll look at the code example. This is using a lot of messaging back and forth to communicate between what we've just spawned. And the communication channel between the two is known as the IPC, inter-process communication. It's a lot to take in. I know, I get it. This is why we're not going to be tested on it, right? But it's, like I said, good to know. All right, so let's see how we spawn, we fork a child. So this is a fork. So we're forking it. This is the example here. And let's run this guy first, make sure he runs. So 3 dash. All right, I'm in the wrong terminal window. By the way, if you ever want, I'm in the advanced folder. If you ever want to, I have a couple terminal windows. You can flip between them if you recall in our bash shell. There's bash. You can also just click the garbage can to delete this guy. And I'm signaling a kill on this terminal window. And now I'm going back to the one I want to. So I want to run 3 tab. All right, let's run this guy. Started, and you can see it started it. message sent is completed. All right, so what happened there? It actually did capture this message here, right? And we set a timeout. So what happens if we reference this Timeout JS. I don't know what's in it. Well, I imagine there's like a delay. We're listening for a message, and then we're going to kickstart the child, but we're going to give them a timeout. So you can see here, this literal. Object literal is the payload. It has a command, which is start, and it has a timeout of 5,000. I don't know what's going on in that file. The child knows. So if I put I don't know, some extra symbols there, I'm sure it's listening for this event or listening somehow. It should not start. So if I fork it, you can see it never starts. It's basically hung up now because it doesn't understand our command. So you can see if I got to Control C, Control X, sorry, Control X, Control C. Maybe I want to increase the timeout, so I did that. And then if I run this guy now, same guy, you can see it started 1, 2, 3, 4, 5, delay, 6, 7, 8. You can see messages sent back, completed. All right, so I'm in the parent, and I'm communicating, I'm triggering the sending, and I'm listening, and the parent is sending back that he's done. Sorry, the parent is sending me first the message, and then I am sending him back done. So what happens if I don't actually send the done message? Let's see. What happens if I just kick this off? I start it up. Started, message completed. Okay, so I sent a request to the parent to start. He sent me a message back saying, here's the message, but I did not send back this message to complete. So now we got the situation again where we're hung up. So I need to do Control X, Control C. And if I want this communication to end, I need to trigger this message back. So this is basically a message from, this is the parent message sending done to the child process, right? That's how you would do it. If he does not receive it, he will not complete. So now you can see message completed, and then I don't have a handler in that timeout, but he's exiting out. So that's pretty cool. Yes. We're gonna see what's next. Yeah, I just wanted to show from the outside what's happening. And then the timeout.js, what does that look like? So it looks like this. The timeout is just using the global process, but you got to remember when we spawn the child process, it's within its own like scope. This process would refer to the branched or forked child process. So that this refers to, right, process is actually equal to the child process internally, right? So what this is saying is, okay, the child process is going to listen for the event, the message, and he's going to check, is the command start? Because if it is command start, then I'm going to do a timeout, giving the timeout that the parent gave me, and then I'm going to send back to the parent. So this would be child to parent message. Sorry, child, this is the message back to the parent, right? The communication goes back out that way, and then of course we know the parent is already listening for any message coming back. The message that he's listening for coming back is this handler here, message, right? So when I send that back, and that is just handled by the send event, right? That's the send event. So the send function will trigger that message event, right? And then if the command does not start, if it's done, then, well, I'm just going to exit the process. That's all I'm going to do. If I wanted to, hey, let's try to do this, right? So let's put a listener on this guy here. So process on exit. All right, exit. When the child process is going to exit, I'm just basically going to say, all right, console log child is exiting. And run this again. Started, message is completed, child is exiting. So now child process has exited, it's finished. Our current running process, sorry, the parent basically exits as well. So that's pretty cool, right? You can have a child, you can fork it, but we only forked one. So I want to see, okay, what does this guy do here? This one, this is just, okay. Do I have that file? So this is saying we have child process script, child.js, so process on message, child got message, process, send foobar. So I don't think I have that script for child.process, do I? No, I think this is the child process. Okay. Let's take a look at the parent. Will the child process die if it does not exit explicitly after the parent exit? No. So if the parent exits and the process is spawned, right? He's out there. It's just another process. Now the system needs to handle that process, right? Like the parent does not really, when the parent that triggers it ends, those other child processes can continue on and managed by the system, right? Until they finish. It'd be kind of difficult to, I guess, you could spawn 100 child processes, which then could go and spawn another child processes, and so on and so forth. So if the grandparent closes, then the descendants close. Like it's a lot of upkeeping, right? That the event loop would have to take care of. All right, so I think this one does not get called directly. I think this is a child script. This is the parent, right? Okay, so this is an example of a parent. We're going to fork that child script that we got, and just same way. What are we going to do here? We're just listening, and this is probably an easier example than the other one. We're listening for, we're just setting up, hey, I'm going to listen for my children to send me a message. That's so nice. Send your parent a message. Cause the child to print hello world. So we're going to send him hello world. And what is he going to do? He's going to say child got the message, and then he's going to send back foobar or whatever, right? So we have communication going back and forth. Let's try this one. Let's take a look at for parent.js. Parent got message, foobar, and then child got the message, hello world. So you can see right away, it started and he sent a message, I sent a message back, right? So it's communication going back and forth between the two. So if the parent dies in an accident, the orphan children will live forever. I don't think that they live forever. I think that the system will decide when the process should die, right? I mean, it's the same way as if you trigger a process on a database and it goes and runs that. But hey, this is advanced node. Let's take a look. Why not? Node parent process exit. Does child process live? Let's see. Okay, well, if it doesn't give me, let's see here, everything you need to know. What does the child process, well, the child process remains alive after parent terminates. Let's see, is that an issue? Blah, 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 blah. So it says the child should have been killed along with the parent. Hey, good point. Let's see, but the child remains alive. Oh, yes, script recursively call itself. Script can recursively call itself. Current workaround is, okay, the current workaround. So this is an example where the child has remains, right? So it remains, we don't want that to happen. How could we kill all the processes? We could use a process on exit, kill all children. That sounds really bad if you say it, but you could protect yourself in this scenario where the child process is alive still, right? So you can handle it, but I mean, you know, if you are spawning many threads, even in threading, you need to keep track of them. So ideally, if you are doing this, have some handlers in for if the case that there is an accident on your parent, the accident can then handle gracefully these long-running processes, right? Just in case it does happen, because it can. All right, so this was that exact example we went through. We had a parent script set up some messaging with the child script, right? All right, we're almost done. What was there? Another one there. So that actually shows, yeah, the child processes and how to spawn and fork them, and the communication that goes on between them. You can also send signals to each other if you wanted to, and terminate them if you wanted to, right? Or like that example showed, on exit, you could actually kill that child process, right? That would be something like this. I don't know. Let's see, dot on. If my process is exit, then I want to, some screaming in the background. Somebody's not getting their Roblox, it sounds like. So I want to just kill process, the child process. Exit. We know that may happen, right? It may happen, and I don't know if this is an example here. We go Control X, Control Z. It should actually, I guess, when we terminate it on exit, I interrupted it. So I need to get a little bit. I need to trigger and interrupt. But yes, the other one was all right. So we went through that, and there's one other module I want to look at, but I don't know if I have one example of it. So this is another example, and there's 3 slides left. This is the last topic. This is actually called the cluster module. So the cluster module, now we're getting even deeper, right? So this is the last step. So Node.js is single threaded by nature, by default to use a single core of the processor for code execution. Cluster scales an application execution on multiple processor cores by creating multiple worker processes. So now this is getting even deeper than just forking, right? Cluster module uses the forking processes similar to the old fork to maximize the CPU. So this will do it for us. It'll fork internally for us. So if we want to spawn 10 worker processes, we can without having to go and fork each one. We can create a cluster. Masters and workers, a round robin. So let's see, it's been a while since I've really shared this information with people. So if there are answers to our questions on any of one of these, maybe it will be in here. So the cluster module is that parent master process that you can fork any number of child process workers. Communication happens through the master and all of the workers through this IPC, inter-process communication. Worker process share a single port, therefore requests are routed through that shared port. Remember, there's no memory sharing among these processes. So you can see here, around robin, we have different workers on the thread. And this is just an example here. So that's the last slide, but I have the code for that, and we'll quickly take a look at that guy here, this cluster module. It does a lot. So let's run it first before we step through it. This is the last example in case this is really burning your eyes. Node 5. So you can see here, master is about to fork a worker, It forked 1 worker, forked 2 worker. Online event 1 and 2. Worker 1 is ready. Worker 2 is incremented. Worker 1 is doing its thing and worker 2 is doing its thing. All right, what happens if I Control X, Control C? All right, so let's see what happened there. What did we do? Okay, so you can see. All right, so let's actually do this. Let's put this to 10. I want to spawn 10 workers. Let's actually bring this guy up so we can actually take a look at this a little better. See how it outputs. So I want to spawn 10 workers. Wow, you can see that. You can see how many. 1, 2, 3 is ready. They all come online at different times. But I have 10 workers that are ready to go. Cool. All right, so ideally the system should do some garbage collection, and if these processes are running for a long time, should take care of them, but there is a way to destroy them all. So let's take a look. We have a cluster module. I don't know why this is here. It's not being used. And then we set the number of workers, and we have a counter, okay? We have the cluster module, and we want to fork. We want to do cluster on fork. So we're going to listen to this event called fork. Every time a new child is created, we're going to say master created a forked worker with this ID. Every time the worker's online, this is the online event. So I guess we forked it, and when he's online, he's ready, and he's going to report back. So this is setting up the listeners. And then we're going to listen, right? We're going to say, all right, cluster on listening. So we're listening when the master's listening for the worker. So now when the workers are online, the workers are going to report back their ID, their address, their port, because they could be all over the place, right? Okay, so we got all of our event handlers set up here. And then we're going to listen to exit, master exit event. All right, master exit event worker. So all right, so it's going to say when we're exiting, master event exit in the worker ID. Okay. All right, so this is where it gets a little bit complicated, but like I said, we're not testing on this, right? So we do have a very important flag to test which process is the master, the parent. Cluster is master. If the current running process is the master, fork all the workers out. So we're going to go and fork 10 workers, 100 workers, we're just going to fork them. When, of course, they come online, they're going to report back, and then we're going to be listening. All right, what happened? What else happens? Subscribe to all those events. So we already know what the events look like. Otherwise, if the current running process that's been forked so it's going to basically run through this again. If he is not the master, he's going to say, hey, I'm online, I'm ready. It's going to increment the counter. He's going to output something if you notice, we actually can destroy a worker, right? So we can say I guess we destroyed the third worker for some reason, cluster worker.destroy. All right, so we could expand this. We could expand this to say, all right, if it is the master and I'm closing, go and destroy all the workers that are attached. Iterate through all of the attached workers in some way and try to go and terminate them all, right? We could do that. But this is it's just clustering, a way of creating. I mean, if we created I don't know, I could create only 10. What if I did 100? I don't know, what if I did 1,000? I don't know. We're going to see a lot of things created and how they're all reporting back, right? Let's go. So you can see I have 100 forked children. They're all online. They're all ready, right? Ideally, they have when I die, eventually, when I terminate, exit event, and all of these, you can see they all actually reported. So it'd probably be smart inside my code somewhere. Let me see here. So on this part where it says the master is about to exit, okay, it might be a smart idea to how do we do it here? Worker dot, does it have a kill command on there? Sorry, worker dot destroy. Worker dot destroy. So this would be a way of, okay, when the parent is being exiting, go ahead and try to destroy all the worker child processes, right? So you can see here, they're all online. They're all waiting, 100 of them. I do Control X, Control C. It exited and they destroyed all those 100 workers, processes. All right. That is node scalability and cluster module. I'll just stop recording there.